I'm Steve Forrest. I'm Vice President for Research here at the University of Michigan, and I'm very, very pleased to welcome you to this two-day conference on building and supporting an innovation ecosystem in our state where the best ideas in clean energy will be able and more effectively move seamlessly from the lab into the marketplace. But first, I'd like to thank the organizers and all of our sponsors, but particularly I'd like to thank the Department of Energy for its interest in sponsorship, and also the Michigan Memorial Phoenix Energy Institute for really helping to put all this together. And by the time you're done, you will be able to say Michigan Memorial Phoenix Energy Institute 3 times without stuttering. Of course, the University of Michigan is deeply committed to strengthening its role in the state's innovation ecosystem and to be engaged with a larger community beyond our academic boundaries. A significant portion of our $1.2 billion overall research expenditures at the UM is in energy, whether in collaboration with our Chinese partners on the next generation of clean vehicles, examining the promise of Great Lakes wind power, making major advances in solar and thermoelectric energy sources, or studying the possibility of turning wastewater into fuel for electric power. The University of Michigan is providing fresh solutions for our energy future. We are also building a strong infrastructure to help transfer that knowledge and ideas developed on campus into the marketplace. So I'll just give you a couple bullets of things that we're up to these days. Over the last 10 years, we have been spinning off companies at a prodigious rate of 1 every 6 weeks. We are truly one of the nation's leading institutions engaged in this type of economic development. In January, we launched the Venture Accelerator at our new North Campus Research Complex. It provides space and resources for our startups emerging from UM technologies and help them to gain a firm and established foothold in the marketplace at an early stage. Perhaps some of you will have an opportunity to visit this facility while you're here at the University of Michigan. I hope so. And finally, our Business Engagement Center was launched just 2 years ago as a one-stop concierge service or entry point for businesses seeking to engage with UM. And it now works with hundreds of firms every year. So today we're here to learn how we can all work together to get even better at this very, very important task. And even more importantly, how Michigan can become a leader in solving the vast energy challenges that confront our nation and our planet every day. And at the same time, we want to be using this new technology to rebuild our own manufacturing base here in Michigan and in the industrial Midwest, which is truly the manufacturing engine of this continent. Now, rather than take your time up more, I really want to get on with the program, so I'm going to introduce Rosina Bierbaum, the Dean of the School of Natural Resources and Environment, who will then introduce our keynote speaker, Dr. Henry Kelly. So, as Vice President for Research, I've worked with Rosina for 5 of her 10 years as Dean. Under her leadership, the school's research budget grew from $3 million to more than $13 million, and enrollment rose by more than 40%. She led a renaissance in environmental research and teaching at SNRE, another acronym you have to learn very well here today, while also serving as leading voice for the cause of sustainability around campus. Through her service on many federal research boards and committees, particularly as a member, I believe, co-chair of the International Panel on Climate Change and on President Obama's Council of Scientific Advisors, she continues to play a leadership role in shaping the national dialogue on topics ranging from clean energy and climate change to adaptive ecosystems and sustainable cities. Although she will be stepping down as dean this year, we're grateful that she'll be returning to the faculty after some time away to lecture internationally and to work as a fellow at the World Bank in Washington. Please join me in welcoming Dean Rosina Bierbaum.
Thanks. Good morning, everyone. You should all feel free to come to the front. I want to welcome everyone to Revitalizing Innovation in Michigan for Clean Energy Manufacturing. We're very honored today to have Dr. Henry Kelly as our keynote speaker. He's the Department of Energy's Acting Assistant Secretary for Energy Efficiency and Renewable Energy, and it's a great personal pleasure for me to introduce him since he's been a longtime personal friend and colleague with whom I've worked since, I'm shocked to say, the 1980s. First, we worked together at the late, great Congressional Office of Technology Assessment, and then we were both at the Office of Science and Technology Policy in the White House. There, Henry was the Assistant Director for Technology, and I was the equivalent for Environment. And usually, I think leaders are either great at vision or really good at keeping the trains on time and details. And Henry is actually great at both, at vision and at the details, which makes him a wonderful and rare anomaly. At DOE, he is currently driving innovation to put 1 million cars on the road by 2015 that are very different than the cars we have today, to make our nation's buildings 20% more efficient, to make solar systems $1 a watt, to have the U.S. obtain 80% of its electricity by 2035 from clean energy sources. Equally innovative in the 90s at the Office of Science and Technology Policy, he played a key role in both envisioning and then implementing innovative science and technology initiatives all throughout the federal government. So he designed and implemented major research partnerships that were aimed at breakthroughs in environmental performance of cars, the Partnership for New Generation of Vehicles. He worked on breakthroughs in housing, the Partnership for Advanced Technology in Housing called PATH, and the first biofuels initiative that was aimed at producing fuels and feedstocks from renewable biological resources. But that wasn't all he worked on. He convened the Presidential Information Technology Advisory Committee and translated the advice that he got into a real expansion and refocusing of federal information technology research. And that wasn't all. He was also instrumental in creating major federal programs in learning technologies for children and for adults. And he worked on the Comprehensive Test Ban Treaty and a range of nuclear disarmament issues. So quite eclectic and quite broad. And back at OTA, the Office of Technology Assessment, he was a senior associate for energy materials and the International Security Division. And the reports I watched him lead while I was there were on such varied topics as solar energy, the economic transition, and nuclear weapons policy. So in addition to his current position at the Department of Energy, his 7 years at the White House, his 11 years with the Congress, he has other work experience, which included positions at the Arms Control and Disarmament Agency, the Solar Energy Research Institute, and most recently, before DOE, this time as president of the Federation of American Scientists. Henry Kelly's an elected fellow of the American Physical Society, and he was winner of their Leo Szilard Award for, quote, promoting the use of physics for the benefit of society. He was also named a champion of energy efficiency in 2000 by the American Council for an Energy Efficient Economy. He's the author of many books, some of which we use as textbooks here at Michigan, and numerous articles on a whole range of science and technology policy. Dr. Kelly was born in Elmira, New York, and he was trained as a physicist at both Cornell and at that Michigan of the East, Harvard. So he's well trained. So let's welcome this brilliant scientist and public servant who has innovatively advanced information technology, education, nuclear disarmament, and all of renewable energy. Henry, come to the stage, please.
Wow, thank you. And I hope all of you realize what a treasure you've got in Rosina. She has, if there's any single person that you can say has driven U.S. environmental policy forward, indeed world environmental policy, it's Rosina. So I think we all owe her an enormous debt of gratitude and wish you enormous luck at the World Bank and hope to see you back in Michigan. And thank you, Steve, for your kind opening remarks. And I also want to thank Senator Stabenow, who's going to be talking to you, I guess tomorrow, is one of the certainly one of the leaders in clean energy and in manufacturing renaissance. So this symposium is about innovation and the role that Michigan can play in reinventing American manufacturing and reprising the key role that it's played in inventing and reinventing the American system of production. And I'm particularly interested in the way that innovation in the state can help the U.S. meet its challenges in building a strong economy while at the same time building it on clean energy technologies of various kinds. And if we do this right, we can certainly find a way to promote prosperity and find solutions to a very pressing set of energy and environmental challenges in many different areas. But all of this is going to require unprecedented investments in new inventions. It's going to require businesses willing to take risks and invest in these new ideas. And it's going to take workers with the skills needed to actually support these and turn ideas into businesses and jobs. Now, the challenges are very clear. The U.S. runs a very large trade deficit in advanced technology goods, increasingly even in clean energy goods, including things like wind machines and photovoltaics, batteries, and other devices. And the painful thing is that this negative trade deficit in many cases is built around our importing products that we've invented here. So this is a challenge that we've got in front of us. We're turning this high technology export problem around, but clearly we have a lot more work to do. So my remarks today are going to focus on three things. One, making the point that innovations in manufacturing are key to the nation's economic future. Second, that innovations in clean energy technology are a crucial part of this manufacturing renaissance. And third, that innovations in manufacturing will require some new ideas about the way government, universities, and industry work together. So why is manufacturing important? Well, one obvious reason is that jobs in manufacturing pay on the average of 25% more than the average job. They're good jobs. But perhaps even more importantly, the ecosystems of suppliers and production built around manufacturing are really key drivers in American system of innovation. Nearly 2/3 of all scientists and engineers work on, are supported by manufacturing firms. And 70% of all the money spent on R&D is directly associated with manufacturing. Manufacturing is clearly at the center of the American process of innovation. Now, we still have a huge manufacturing base, and we've been the world's largest manufacturer since the 1890s. This is a record that we may be at risk of losing. But because we're facing very smart and determined competitors around the world. U.S. employment in manufacturing is now around 10%, about a third of what it was in the 1950s. Now, we're confident that the program we've put together in the past few years is going to build dramatic new growth in manufacturing, and clean energy technologies will be a key part of this solution, but we've got to be smart about how we do this. Now, there's plenty of evidence in many of the most exciting new areas of production. We can, in fact, compete by even with the lowest wage producers by meeting the president's challenge of being able to out-innovate and out-educate our competitors. There's a lot of uncertainty, of course, about exactly the direction that this new manufacturing paradigm is going to take. It's very clear that the new American system of production is just not going to look like the system that was in its heyday in the 1950s. There's a lot of uncertainty, but I would certainly expect that the new system is going to have some of the following characteristics. First of all, most of the new products will need to be a part of an integrated network or system. Instead of severing the connection between a product when you sell it, many of the manufacturers will continue to support the product through services, through communication networks and other networks. For example, electric charging or possibly fuel cell charging will require completely new delivery infrastructures. The vehicles will be equipped with systems that can improve safety, reduce maintenance, and facilitate charging and fueling. Just yesterday, we made a partnership with Google so that you can find electric charging stations on your Google Maps. a new electric grid will be able to link smart equipment with smart buildings and manufacturers and smart electric production. Many buildings, aircraft engines, industrial equipment are already continuously communicating with the facilities that produce the equipment to begin with. For example, advanced wind machines have dozens of channels of communication that basically phone home continuously, and where the original producer of the equipment can keep track of the performance and send maintenance crews before things go wrong. What all of this means, of course, is that the boundary between manufacturing and services is increasingly blurred. They're going to have to advance together. Second, the production processes themselves are going to have to be integrated systems. The Defense Department did a large study recently about why they're suffering huge cost overruns on producing new equipment. And they found that most of the problems happened at what they call the seams, separating the different parts of production: design, prototype, limited production, high volume production, quality assurance, and deployment. Frequently, when products cross these seams, problems come up. A design that is a brilliant design may be utterly unmanufacturable, and you have to go back and redesign it, causing continuous delays and cost overruns. So the new system is plainly going to have to do things like involving the production and manufacturing people at the same time you're doing the design. And there's some existence proof of this. The semiconductor industry, for example, has had an enormous increase in the complexity of their products, but the design cycle time is essentially the same as it was 10 years ago. So they have done it precisely because they have been able to integrate all parts of the industrial design and production systems. And finally, flexibility in adapting new designs and fast and efficient production systems and other features of modern production are going to be essential to be agile enough to be the first mover in many of these crucial areas. In many cases, the adaptability of a cluster of innovative firms is going to be more important than low wages or economies of scale. Now, elements of all of this are in Michigan. Michigan clearly helped invent the first American system of production, and we're going to have to count on it to invent the next one. The state has led the world in manufacturing everything from cars to office furniture to sophisticated chemicals to cornflakes. The invention of the automobile mass production, of course, reinvented mass production. Dow managed to establish a production system that undercut European monopolies. In fact, I was talking to some Dow guys a couple of days ago who confirmed that this is not an urban legend, but that Dow was producing bromine, and the Germans tried to undercut by dumping bromine into the American markets. Thank you. At very, very low prices, but the Dow guys figured out that the price was so low they could buy the bromine, ship it back to Germany, and undercut the Germans back in their home country. These are the kind of guys you definitely want on your side. And Michigan is also leading the way in clean energy production. Clean tech is the state's fastest growing sector, with $10 billion in advanced clean energy development investments already in the pipeline. The state ranks fourth in the nation for the number of jobs in the solar energy industry and seventh in patents. In fact, there are so many patents coming out of Michigan that the U.S. Patent Office is opening its very first branch office in Michigan, in a regional division that's going to employ 100 people. It's really a testimony to the productivity of this area. Now, the Recovery Act was critical in helping to accelerate the transition to alternative vehicles in a clean transportation sector. And this included $2.4 billion for battery and electric drive component manufacturing. And there are new facilities here in Holland, Romulus, Midland, operated by Johnson Controls, A123, and Dow Kokum. And while the U.S. share of advanced battery production was around 2% a few years ago, we're convinced that we're going to capture a very large share of the world market in 2 or 3 years because of this investment, and put us well on the track to meet the President's goal of 1 million electric vehicles on the road by 2015. Now, while electric drive provides some very interesting alternatives, there's plenty of runway in front of us on improving advanced combustion engines. We have a program with heavy support from Eaton here in Michigan to double the efficiency of heavy trucks. There's some very clever hydraulic hybrid technologies that is being done involving Eaton and the Ann Arbor EPA lab. And there's a lot of runway ahead of us in many, many other areas. Michigan I was astonished to see it has the longest coastline in the lower 48 states. This fact was given to me by a Michigander, but it seems to be true. And because of this, there's a huge opportunity for offshore wind. Apparently, over 130 gigawatts of wind potential in shorelines that are shallower than 45 meters. But let's not kid ourselves. There's no guarantee that the momentum that I've just described can be maintained in the face of fierce international competition. The Chinese and other competitors have figured out that they're not going to be able to build their prosperity on low-wage production. They want to find a way to out-innovate us and be not just copying what we're doing, but leading us and being first movers in. And this includes innovations in clean energy technologies. Now, clearly, Michigan is only going to be able to survive in this highly competitive world by being even more agile and more creative. And most of the pieces needed to prevail are in Michigan: critical manufacturing infrastructure, a great university system. But we'll really have to step up our game to prevail. And this is going to require some institutional innovation as well as technical innovation. Now, the recent deep recession obviously has taken a big toll on Michigan in many ways, including its research infrastructure. But as it's being rebuilt around clean energy, this also provides a key opportunity to rebuild a new system of innovation built around these new ideas and new possibilities. And so that brings us to the questions that I'm hoping that you can help engage here in this meeting, and answers questions like the following. How can the work of Michigan's great university be better aligned with the challenges of building a clean energy technology? Now, nearly all of Michigan's engineering programs rank in the top 10, but I've heard concerns that there's not enough connection, not enough of a strong tradition connecting these very innovative departments with spinning off startups, entering research partnerships with other companies. And there's also concern that students emerge with a skill set that may not be as well matched as it could be to the needs of emerging companies. For example, power electronics, electrochemistry are once thought to be kind of the backwater of chemistry and engineering, are really now at the core of a lot of clean energy technologies. Now, Steve Forrest in his introduction talked about a lot of incredible things that have gone on here already. But the question is, can or should more be done? What does it look like? And in particular, how can federal agencies help him and help all of you? Now, the finance community in Michigan has got to find a way, a better way, to back new products and new product ideas. We've got to make it more profitable for people to invent in innovations in clean energy technology than to dream up financial gimmicks that seem to be dominating the wealth creation in the U.S. Venture capital funding is still very heavily concentrated on the coasts. Looking at the Venture Capital Association data, the venture investment in Massachusetts was 16 times bigger than it was in Michigan. And that's certainly not because there are 16 times more ideas in Massachusetts. How do we fix this? What's wrong here? And deregulation and other factors have meant that some of the great, or I should say virtually all of the great corporate research laboratories have been radically restructured, both in size and scope, and pretty much forced to narrow their scope away from basic innovative research and on product-oriented development. And the federal national laboratory system can substitute to some extent, but clearly can't completely substitute. We need some new ideas here. And we've been exploring some ideas about ways to build better research partnerships with business and universities. We've got our energy frontier research centers. We've got a new family of hubs which are designed to try to bring partnerships together around focused ideas. But we have the sense that this portfolio could be very much improved. So we'd very much like your idea about, what kind of experiments we should run, what's succeeding and what's failing. Where do we go from here? So building a future that links prosperity and economic sustainability is going to require some very dramatic changes in the way our economy works, including the way our innovation system works. But it is going to change the way we travel, the way we generate electricity, the sophistication of our electric grid, the way our industrial system operates. And it's plainly possible for us to do all of this, but we're not going to get there without being willing to reinvent ourselves in many ways. And the president talks about the challenges of America's economic and energy Sputnik moment. And the Cold War threat that was referred to by the Sputnik challenge to begin with spawned an entire new generation of research infrastructure, the formation of DARPA, huge increases in the National Science Foundation. A generation earlier, Michigan did what was seemingly impossible. It, faced by the threats of World War II, it completely rebuilt the automobile industry into a war machine in a period of months. So something very much like a similar crisis-driven response is underway today. We're in the middle of it. We can see the rapid growth and reconstruction of manufacturing in Michigan and innovation in Michigan around a clean energy technology. President Lincoln actually was talked about defining progress as finding a way to mix the fuel of interest to the fire of invention. Well, there's plenty of fuel and fire in Michigan, and shame on us if we don't find a way to take that opportunity and build a better world that we'd be proud to bequeath to our children. So thank you for having me. I look forward to discussions. It's very interesting to see what you conclude. So good luck.